3. This x in the the second one implies that x is cannot take value of 2 and cannot take value of 3. Yet in bisection method, the x has to take values of the boundaries, because we have to test what is the sign change in the boundaries. So that is the reason as to why we are using those two. So let's do number 1, the first part. We want to show that the root lies between that. So what do? We find f2. What is f2? By f2, we mean that we are going to substitute 2 in the function. The function, if we can recall, fx is the same thing as x power 3 minus 2 x minus 5. Then we are going to substitute 2, so we'll have 2 power 3 minus 2. Let me tell this kid to keep quiet. So 2, you see, when you stay home. Last time I wasn't home, that's why it was so quiet. 2 minus 5. So what is this from your calculators? 1. I am not calculating anything. So you need to be -1. Okay. Now we also compute for f what? 3. This gives us 3 power 3 minus 2 times 3 minus 5. We have 27 minus 9 minus 5. That gives us actually we're supposed to write check, because we are checking what happened.
Give us 16.
16, eh? Therefore, how do we conclude that since f2 times f3 is less than 0, it's a negative, therefore, the root, actually we use there, then we use the Newton's conclusion. Then there exists at least one root, a root of the function in the interval 2, 3. So that is the conclusion. You check for f2, check for f3, and then you write this, and finally you conclude like that. That implies that there is a root in that function. I mean, in that interval. I think let me just move away from this place, because my people are not going to keep quiet. Just 1 minute as I move away from this room.
Uh, Susie and Adrian, there's something you guys were talking about with Mr. Ssengendo about a platform, Python programming. What was that?
So with this with the numerical analysis, the stuff that we are writing, almost everything you need to write an algorithm for it. So besides just finding the bisection method, there's a part whereby you need to write an actual code, whereby the code will have to be in maybe Python. And that's because he was talking about it because of the questions that he uploaded on Planet for Cat 1.
Okay.
Yeah. So if you did any Python or you've done some programming, you should be able to write the code using the function.
I heard you mention something about a platform for the exam,
For the what?
for like the exam.
The Planet. Yes. We uploaded the questions already in week 8.
Okay.
So can we continue? Are you done?
Yes.
Okay. So that is part A. So we proceed to part B. Part B is requiring us to do what? This thing. Part B is requiring us to use bisection up to the fourth iteration to determine the interval within which the root lies. Therefore, the first thing I normally advise you to do is to draw a line like this, and then you write the numbers. We have 2 and 3, okay? Because it is going to help you now which interval are you going to take next. In the first place, F2 add a negative sign, F3 add a positive sign, just like that. I don't know whether you're following. So I put negative here and then I put positive. That is going to help me to decide now which interval I should look at after. Okay, now we continue to the first iteration. Iteration 1. Iteration 1, I'll abbreviate. What does iteration 1 claim? We want to find a C. The C is the midpoint of these ones. And that gives us 2.5. Therefore, we check. We do a check. What is f of 2.5? We substitute 2.5 in
The
the
function.
other function.
Function.
What is the value? I did not come with a calculator today. I was sending my daughter to get it. Eddie. Wakebera mudraw.
5.625.
You say 5,
0.625.
5.625. Okay, that is true. Let's go now. Let us, this function, the value is positive, not so?
Yes.
Therefore, we identify a 2.5. 2.5, let's say it's somewhere here. And I'm doing that because I know where the function is going to come. I mean, to go next. So this is 2.5. And here I'm getting a positive value of the function. Okay? What does it mean now? What is the new interval?
The new
It's 2
interval becomes 2 to 2.5.
New interval will now be 2 to 2.5. Why? Because this is a positive here and a negative here. We cannot take this one. Why? Because all of them are positive. I hope you are following.
Yes, sir.
Now we go to the second iteration. Iteration 2. Iteration 2, still we get a C. Okay? So iteration C now, I mean the C becomes 2 plus 2.5 out of 2. This gives us 2.25. Then we get F 2.25. Substitute and see what we get.
One point 890,625.
Let's write 3DP 1.891.
91. 1.
Okay. I hope even other people are checking so that we avoid
Yes.
mistakes. Now this is a positive. We needed to locate where is 1 point. I mean 2.25. 2.25 is before 2.5. So somewhere here 2.25, and here we are getting a positive value. Okay. So there are Michael. This is Michael. I don't know what is the problem. Let me mute him. Let me just. Is he in church? What? Mm, Let me try to mute him from here. Okay. But if he's in vibe, I mean, does it have to affect us? Okay. I've even okay. My thing now is okay. I'm back. Okay. Right. So 2.25 is there. So this is a positive value, and that means that the new interval now becomes
2.5.
2.25. Okay. Now we go to the third iteration. Once we get the interval, it takes us to the iteration 3. Okay, iteration 3, still we need to find a C, which is 2 plus 2.25 divided by 2. That gives us
2.125.
5.
2.125.
2.5.
25.
Okay, 2.125, and then we need to evaluate F at 2.125. This gives us
0.346.
0.346.
46.
Are you seeing a 0? As if there is a root now. Initially it was 1, there was no root. Remember, for R to be a root, for R root, it implies that R should be in the other interval that we stated. And
Yes.
also, if R should give us what?
0.
0 for R to be a root. So we have observed the 0. That means that probably that is an approximate root, if that is the interval that we are to stop at. Okay, let us continue with now the fourth iteration. So the new interval now becomes the new interval becomes 2 now. Oh, before this is 2.25. 2.125. It is here
Yes, sir.
before 2.5. So this is 2.125. This was a positive. Therefore, the new interval is 2 and 2.125. Okay. All right. After getting the new interval, we get the C now. We go ahead to compute for the C. The C becomes, the new C now becomes, this is now the next interval, iteration, which is a 2 plus 2.125 out of 2. You have just mentioned it is what?
2.0625.
625. Now we evaluate the function at this value to give us
Negative 0.3351.
351.
Yes.
Okay, this is negative. More negative compared to the one before. So remember they told us that we stop at 4. Therefore, we're going to judge where the root is. If you are to stop at 4, this is more negative compared to this. Are you aware?
Yes.
Yes, sir.
Therefore, the conclusion is much as that we have stopped at 4, but at least we see a value that is more likely to be a root than this other one, the last one. Therefore, we are going to conclude that the interval is 2 and 2.125. The lower one, I mean the one before, okay? The one before, because it is more, when you look at this, it is this function attained a 0 first on this on iteration what 3, as compared to iteration 4. Iteration 4, it is going beyond the root. Talk about this situation. Let's say we have x and y, and then we have our function in red. Then it comes, it reaches the root, and then it continues. So it's like iteration 4 is somewhere here. Iteration, okay, let me make it bigger. Iteration 4 is like somewhere, if I could, so this is how it is. Iteration 4 is like this one 4, but 3 is like somewhere here. Okay, actually not somewhere there, it's up here, but close to 0 as compared to the other next one, which is also down but still close to 0. So anyone, if you're given a chance to pick between a negative, because we have 0.346 and a negative 0.351. So this one is in negatives, but it is also far away from the root as compared to the one which is positive. I don't know whether you see that.
Yes.
If
Yes,
I
sir.
was to take the first two digits, the positive is that and the negative is 0.35. So this one is more by 0.01 unit down as compared to this one. And in reality, we normally like the positives as compared to the negatives. So if you are to pick a value, we rather pick the positive as compared to this. That's why I'm saying that the root now lies in the other interval, which gave us a 0.346. And now, having said that, I think now we can determine the approximation. What is the approximation of the root? That is part 4. Part is it part C? Yeah, part C. What is the approximation of the root? C. The approximation of the root is, what is this? What value did we get? It is approximation of the root is 0.346. Okay, that should be, this one is in 3DP. That should be easy for us. Understood?
Yes, sir.
Now, you're going to try this one. You're going to do the same things in this example. You show that the root of the function, which function? This one. Let me use red. This function fx, which is equal to e x minus x power 3 minus 5, has root in the interval. The interval for this one you're going to use is -2, -1. You do the same thing for part B and part C. All right? Power. Yes. All right, I think we can start our tutorials. Did I share the tutorials? No. There is this one. I don't know whether you see. No, you're not seeing that. Let me stop this presentation. Then I give you a different one. This. I think there is one more number that I've just added. That. So did I share something like that? Though this one is not numbered. Okay. I've lost what I. Oh, I can check. No, I've been changing phones these days, so I don't have record of what I have done on WhatsApp. That's the challenge. Okay. Can someone reshare what I gave you? Repost as the tutorials. So we are starting. Who is starting? But you should reshare so that we can start again. I mean, I can see what you are doing, and then we start. You have not shared. Okay. So meanwhile, who is doing one? Okay. Meanwhile, who is doing one? Did I just share like this? Ah, can you imagine? I shared it is this one. I was wondering how did it, like, I didn't number, and I'm like, I can't share something that I didn't number. Okay, it should be number 1, number 2, number 3, number 4, number 5. All right, who is working out number 5? And how best are we going to do it?
Okay.
We give someone to present. I mean, to give him time to write, and then he posts or he shares his window. That is if he can write on the screen.
What's wrong with you? Why me? Or is
Why
the
not you?
where is the question? Oh, this is the one. Wait, that's
Or
the question we have in the one
Excuse
that
me,
you
sir.
gave.
or probably if someone could do, we could give them time, they write down, and we like he shares it, and then we view at once, and then we critique.
No, we can all do together, I think.
When I'm
Excuse
not
me, sir.
there,
When
you
you're
do
not part of
together alone when I'm observing.
when you're observing, yes.
Yes,
That's how we normally do our. I
yes.
need to have the question.
The
I'll
question, the
Excuse
question
me,
is there.
doctor. It
Yes,
looks
please.
number 5 is incomplete.
Number 5, we have worked it out.
Okay.
The one we have worked out. In fact, let me remove it. But no, I am going to add some things. That's why I don't
You're
want to
adding,
remove.
you're adding
I'm
the
going
table.
to add No, I'm going to add those statements that I gave you. In fact, as you are working, I'm going to add because I'm likely to pick it one day, either in the end, and then I give it to you
Mhm.
as
That's the
work.
same number that is in cut one, but the other one is requesting for the algorithm.
Yes, algorithm. Okay, so I am observing. You let me know when you're done. But I'm observing as I type this question.
Paul, can you share with me the question actually?
You got the group.
So I give chance for people to share. I stop sharing, right?
Yes.
Okay, done.
I'm going to the group. Wait, I get the question.
I don't see anything in the group.
It is there. I just received one.
Okay.
Oh, you are in the wrong group.
Numerical analysis DL.
That sounds impossible.
You're checking from a wrong group.
Yeah.
I think I'm in a wrong group. It's numerical analysis DL. I don't see anything.
This man. Uh,
Okay, so my job will be to write. The
yes.
contribution is for everyone. Let me share my link.
Today
Where
people
is
have come.
my
Yeah,
code
where
is not.
people have joined so many. Today the
Sorry?
class today the class is full.
Yeah, exams on here.
Hey, I see. Okay. We are waiting for you to share the screen.
Yeah, I'm connecting my tab so that I can be able to write.
And are there some numbers that probably you came across that maybe we would discuss, or even later? But if we shared them here, then we can as well find solutions to those numbers.
This technology sometimes plays all of us. Why is the tab not showing up? I can't write like you during using that app.
We give him, we give the man time.
Thank you very much. That broadcast.
Okay, I see.
Okay. Okay, those that work with me normally they know the drill. My job is to write. Can you guys see?
Yes.
Perfect. So the question that we have is, I'll expand a little bit. So I have P. So we have the error if.
I think that is the second polynomial of x, of function x.
Okay, so it's used to estimate the value of cos x
Yes.
at x is equal to 0.6. So Dennis,
Yeah.
we continue. You tell me what to do.
I think we first have to, the first and the second. The second of that, we should first get the first polynomial of that.
The first polynomial of this function,
And then until we reach on the second polynomial.
which is this one that we've been given.
Yes.
Please repeat the question.
Sorry?
Help us repeat that question, please.
The question said estimate the error in that
Let me read
function
the thing.
is used to estimate the value of cos x at x is equal to x is 0.6.
Estimate.
The error.
You bear with my handwriting. I was supposed to be a doctor.
So what stopped you?
That's a discussion for another
What
time.
happened?
So we agreed you're going to keep quiet.
I'm sorry, I'm sorry.
So that one is discussion for another time. So estimate the error if is
If
that P?
that is used to estimate
Is used.
value of cos x at x is equal to 0.6.
So those that were asking the question, that's the question. Okay.
Yes.
Well, of course, this is new to me. The P2 means that's the secondary.
That is the second polynomial.
Okay. So we find the Dennis, you were saying. So
That is
solution.
the second. If they say estimate the error in a second polynomial of that,
Please go ahead.
let me first write it down and see. P2
So you could just tell us and I'll be writing. Otherwise,
Paul, you can also
my job is
write. I'm still trying to see how I can write it.
this question. I have no idea on how to solve it. I can do number 2, but not this one.
Can I help a bit?
Yes, sir.
Write the formula for error. And then from that, you write the formula for error. You write the gem.
Yes, I'm listening.
You're right.
Sorry. Oh, okay. That would be. Did you say X? No, my friend. That's the one. Whereby Z is equal to, it's between X and A.
You have written a 2, not Z. Doesn't it look like a 2? Yeah.
If you
If you want to write a Z, you can put a R at that one. It's better. Now, if it is second polynomial, what will be N? Really?
Will be 2.
Huh?
Will be 2.
2. Now instead of N, write 2 everywhere. Okay, substitute N is equals to 2. Then we see what we want now.
that becomes F of 3
Mm-hmm.
X minus A power 3
Yes.
factorial.
But this is R2.
This is now okay. Yeah.
You leave that one on the second part, on the second line. R2. It's better to write therefore R2 is this.
Okay.
Now we can we evaluate F3?
F3 using what we were given.
Yes. I'm waiting for you up to R3, then I come in.
Okay.
Get F3, then you substitute.
Okay. So would I be right to write like so F of X is equal to 1 minus X squared out of 2. Then I get the F of 1.
Fx, it will be only X.
No,
Negative X.
that is the error. That's the polynomial. The function is cos X because you check the question, we are estimating the value of cos X. Okay?
Okay. F of X will equal to cos X.
Yes, because that is what we are estimating.
So the F of 1 first cos X, that's negative sin X.
Yes.
Then we need to get the second one. That becomes negative cos X. And
then the third will be
Sin X.
sin X.
we need to get, okay. This now becomes the R2.
Then R2.
That becomes sine.
Adrian,
Yes.
aren't we supposed to substitute in x? X is 0.6. So if you find f of x is equal to cos x, and then you substitute cos 0.6, get an answer.
Because we're given at x, yeah, it's centered at x is 0.6.
Yes, sir.
So please, you come in here. You said when we reach here, you come back. So we get sine.
But you are on the right track. You substitute that, and then you substitute all those other things. That is okay.
Sine of. At least people should be pressing calculators.
You have started from down going up. Okay, it's fine.
The upper ones, we don't need them for sure. So this one becomes 0.0.
0.0105. 0.011.
No, are you're rounding off a 4 to a 1?
5. Are you saying a 7?
0.01047.
Yes.
So let's make 0.5.
Yeah, 0.5.
So we substitute in our okay, my brain stops here.
No, it shouldn't stop. It should continue.
Edwin, kindly, how did you substitute that? Where?
So the question was, we're estimating the error. That second polynomial is used to estimate the value of cos x centered at x, and at x is equal to 0.6. So we go to the third. We have to substitute in sine x, replacing the x with the 0.6 to get the value of 0.0105.
Edwin,
Yes, sir.
why don't you go back to R2? There. Substitute now sine this function, sine x.
Sine x.
Yes. Then times, what is the A?
A is
0.6.
yeah, centered at 0.6. The A is 0.6.
What about X?
A is 0 and X is 0.6.
Yes. Do you understand that? A is 0 and X is 0.6.
Yep.
In other words, that whole thing minus should be 0. What?
0.6.
Yes. Or you just put X cubed. X cubed
over 3.
out of, yes. Now that upper numerator should be in magnitude, the magnitude of all that thing.
Excuse me.
Magnitude of x squared and magnitude of that.
Excuse me.
Yes.
Where did the Z go? I just wanted to understand what
It's
Z
still there. The z is the x in this function, sine x.
Okay.
You get, because I don't know, when he was starting, he said the z lies within that interval, the interval which should be given. But we normally take the extreme limits of the interval. So in this case, the extreme limit is the 0.6 that they have given us.
Okay, okay.
So,
So we were
so
finding Z when we found 0.015.
that is the FZ,
Okay, okay.
but should be in magnitude, remember, because it is an upper bound.
Okay, thank you.
So now we
But
represent.
Edwin, include magnitude signs.
Who is that? Hello?
You put the magnitude of x cubed over 3 factorial in the magnitude.
Let me first.
And also sign.
Sorry? And even the
And
sign.
also, and also sign. Remember the other, yes, because even, yes, okay.
So we continue.
Why R2? Because when you magnitude this side, the other side is okay.
So no need R2.
Yes. Now we continue with that one.
So sine, this was 0.0105. Wait, yeah.
Excuse me, Adrian.
Yes.
So where does the A go? The other A?
The entire
A is 0.
expression of x minus a is equivalent to 0.6.
Okay.
Does it make sense? This entire expression.
Okay. Okay.
Okay, so we have x to power 3. We are taking the upper bound, which now becomes 0.6 power 3 over 3 factorial. Give me the answers. Point. Give me the answer, the entire thing.
Zero.
This is the upper one. Three. Does everyone agree?
Okay, in simple terms, it is 0.00378. 1, 2, 3, 4.
Okay, yeah, I've confirmed it. Okay, so this is the error.
Yes.
And that's the answer? What are we
Yes,
doing?
that's the error and that's the answer. Now, there is something. Are you seeing where you put a 0.0105?
Yes.
That's the value for sine, eh?
Value
Okay.
for sin x.
Yeah, that's the value of the sine x. But we can also put 1. Why? Because we are sure that that value, which you have written there, which is a 0.0105, is less than 1. Remember, the function before was in magnitude form, was the magnitude of that value. And so if we just write 1, still we are sure that it is less than 1. So that can be okay. Or in case you put less than 1, still that is what? Okay.
So does that mean if I wrote an answer like my final answer to be 0.6, that would be a final answer. That would still hold?
That would be still perfect.
Okay.
But that means that this one should be a less than instead of a equal, should be a less than. Because you're substituting a 0.01 with a 1. You get the argument?
Oh, yeah.
And 1 is bigger than 0.05, which means that that value should be less. So when you compute now, the final should be equal to, because the final should be a deduction from the less. Now
So what
down there, write equal to, compute that value. But even the upper one is okay. However, if you see something like that,
I'm confused.
yeah, where?
So this part here is
Yes,
not the final answer.
it's not. Compute that. Write down equal to, then compute that value you have written. 0. Yes. Exactly.
And this
Yes.
becomes the answer for R2.
We will be happy if you wrote this than the upper one. Would be, in fact, will give you more marks here than the upper one. But the upper one is also okay.
Now, what was the use of the second polynomial here in this entire question?
To let you know that it is R2.
Wow.
So, so I have a question.
Yes.
Can in reality can that polynomial be the one for cos x?
Yes, it can. Can we find the polynomial for cos x?
Yeah.
Who can find? By the
You
way,
see, when you use Taylor's series, it's
yes.
not coming out.
By the way, what if we center it at 0?
That becomes macaroons.
What if a special function? Okay, a is equals to 0
Okay.
because
That's where.
for macrolines it is strictly x is equals to 0.
It
And
is
that's
a
But
equals
because
to zero.
that's
is an
because the
a.
A is zero.
There is an a, yes. There is a x and an a.
Yeah, I think when we use that, it can come out. It can.
But don't worry, in the last expression, in the last paper, like examination, I may tell you find the cos, then find the error in the second polynomial. Over in the polynomial above, I'll tell you, write the second Taylor polynomial for approximating cos x at 0.6. Then part B, find the error in the polynomial in A above. Okay, so far so good. Let's go to the second one. People, I don't know, people should copy, I think.
I can put
Or
it
they
back.
can take the screenshot.
Please take a screenshot.
Then fine. Let's continue on the second one.
So number 4, you wanted to do this. So number 2.
Yes, we are saying we are going up to the fourth iteration.
So we'll write our function. We're using bisection. Why? So I want to find if this f of -2 times f of -1 is less than 0. That means we can have the bisection. Bisection can be used here. Okay.
And so, Paul, and also, why are you rubbing? And also, when we have that equation true, it means that the root is there. Therefore, we should continue. But if it is not true, it means that the root is not there. Therefore, there is no need of continuing. You can continue.
So now we write for proper documentation. So we find f of, and what's the answer? Dennis? Huh? Is e of negative, e raised to power negative. What is the answer? Then f
Yes.
of -2.
Isn't it 3.1353?
Okay, let's all redo and then give me the final. Is that Tugume?
Sorry.
Tugume, what's the answer again?
Okay, for me, I got 3.1353
Or which part?
for -2. F of -2.
Same here, same here.
In that
I
case,
also, I also got 3.135335283.
3 point,
Hmm.
3.1. Guys, repeat that.
3.135.
That should be. So is the first one correct?
Yes, it is.
Yeah, it's correct.
Paul, please continue. What is the declaration here? There exists -2, -1. Oh, sorry. Okay. He said we always draw the line. I don't know why. I don't like it, but he wants it. Okay, so the first,
for purposes of organization.
oh dear, iteration 1. So for the iteration we are finding, which is the C, which is equal to negative. Then we find the F. Gume. Negative 1.40. So where will that be found?
Let us go back on the, is it number line? And put that negative 1.5.
Yeah, which side? Which side do you think it's closer? This is a plus.
Closer to the 1.
Negative 1.
No, one Edwin.
Yes.
The number line is supposed to show C. That is negative 1.5.
Oh, yeah, yes, you're right. It's not to the scale, so this will be, so somewhere here. You should accept. Guys, don't complicate my life.
Yeah.
Okay, so now
that one. No, the interval is between negative 1.5, negative 1. One. Then on the number line, it is showing negative. I'm seeing. You scroll up, Mr. Edwin. We see. Yeah, it is a positive. Then you change it on the number line. Yeah, it's a positive. Then negative 1 is negative.
negative 2.
That one.
Then
Then
the one is supposed to be negative.
yes.
In my, because this a little bit confused me personally. The one that I'm using is that if f of the A, let's assume this is the x lower bound and then the x upper. So if f of x lower bound, f of xr, which is the C, less than 0, then my x upper bound becomes the xr. And then if x this is greater than 0, then my xr becomes the xr. And if x is equal to 0, then actually xr is the root. So this doesn't confuse me much compared to this. drawing. That's why I don't want to make a mistake of putting any sign and all that stuff. I try to avoid it. Personally, it confuses me. So I'll just, for example, if I got this, the negative 1.042, sorry, negative 1.402, I multiply, if I go to the f negative 1.5, which is my xr, and then with the lower bound, which is f of negative 2, if I get an answer that is less than, what is the answer actually? This will be 3.
It will be it will be a positive.
So if it's a positive, now I'm going to have, we are replacing this. We are getting rid of the negative 2. Now our actual bound is now going to be negative 1. Sorry, the interval is going to be negative 1.5 and negative 1.
Your method is working, but it consumes more time and work.
Yeah, because even right now, that's what I'm saying. It's a preference. It's a preference. And so now, why, if I may ask, why did you have to put the negative 2 to be a positive on this interval?
Because when we evaluated f of negative 2, we got a positive.
Okay, thank you very much. We continue. Please ignore this middle thing.
Please also change your scale. Make that 2 the positive towards this other side and the negative 1 this side.
Then negative 1.5 is negative also.
Okay, back to this. Draw the line. So now this becomes negative 1. And this becomes negative 2. This is a plus. This is a negative. Then we have something here, which is negative 1.5.
I want to understand something.
Yes.
Negative 1 and negative 2, which comes first?
That's exactly why I get
Negative
confused.
2.
I was also going to ask.
No, negative 1 comes first.
Exactly.
Yes.
Which
The
makes it more
previous thing
positive.
was correct.
Sir, okay, we on a number line supposed to be negative 2,
Negative
negative
1.
1.
No,
Yes.
negative 1.
Negative 2, negative 1.
Yeah, the way it was before.
The way it was, not the way it is now.
Yes.
Let's correct them.
I had that one. What
Guys,
is the new interval?
then a negative 1.
And
And
negative
what?
2.
It is negative 2 and negative 1.5.
Yes.
Okay.
No. It's negative 2 and negative 1.5.
Bwana Sozi, you are taking a different thing.
What you do, write that thing down, because if you don't write, we are going to be you may deny.
So, what is the new interval now?
Negative
Negative
2
2,
and
negative
negative 1.5.
Negative 2 and negative 1.5.
That's right.
So that's the second
iteration.
C will equal to negative 2
0.5331.
You know, a specialist there. 0.5331. Just skip 3 decimal. Okay, 5331. Okay, again, what is the new interval?
Put on our number line. Include negative 1.25 on our number line.
Negative
And make-
1.25 should be closer to this side. 1.25.
No.
This moved here.
Oh, no.
What?
Is it 25 or 75?
Is it next?
75.
Okay,
It's the other way around.
that is true. 1.7, negative 1.75.
That
No,
becomes
you can leave it there, Edwin. No. Okay.
negative 1.75.
Yes. And make it a positive up there.
And this was a positive 2.
No, that one was a negative.
After the evaluation.
The evaluation was negative, Mr.
So now the new interval, since people get confused. This is number 2.
Now, if I write the new interval, then we go for iteration number 3.
Is it the 2 first?
No. It is negative 2 and negative 1.75.
It's because we are shifting this side.
Yes.
No.
No, the answer is in between here. It's negative 1.75 and negative 1.5.
Oh,
Yes.
let me ask you. Where should we get it? Where should we get it?
Okay, are we using... is it the negative 2 is the upper limit? The lower limit?
This was our new interval from here.
Maybe I can explain to him. The interval is in between negative 1.75 and negative 1.5 because Edwin, can you scroll up the line? Yeah, because you see that's where the change of sign is. You cannot say it is in between negative 2 and negative 1.75. They are all both positive.
Which change of sign?
That is greater than 0. So if you
Because
multiply,
we don't have a change of sign at the moment.
one, yes.
What
So
did the negative 1.5 bring?
Negative 1.5 took us to
Negative 1.40.
Negative 1.402.
Which made us maintain.
That was 1. That was 1, not 1.5.
It was 1.5.
How did you get to the 1? Because we have our initial interval is negative 2 and negative 1. Divide by 2, you get negative 1.5.
Because now it's when we are using 1.5, where you are using 2 and negative 1.5.
I'm not getting you actually.
How did we get that one?
1.5. Let's go back.
Okay.
We got this was our first interval, right? The one that we gave. Okay.
Yes.
Our first iteration, we had to find the C, which is negative 2 plus negative 1, divide by 2. You get negative 1.5. We had to find, to evaluate this, we got negative 1.402.
Yes.
On our on our
Okay, I get it now.
Can we continue now?
We can continue.
Okay. Now, what is the new interval now that you've understood? What is the new interval here?
The new interval will be negative 0.1, negative 1.75 and 1.5 negative. Who is laughing?
Mr. First, happy. I was celebrating an achievement because of the good.
So,
I don't know how you interpret it.
to the third iteration. Tugume, do your job, please.
5120.
Negative?
Negative 5120.
Negative 5?
Negative 0.5.
0.5120.
Okay. So that means we are taking this. It should be somewhere between
Negative 2.5 and 1.5.
I'll kill you. It's you who said that our new interval is now between negative 1.75 and negative 1.5. Where are you going to do again?
No, because, let me explain. That one has brought a negative, which means it is less than a 0. Yes? Okay.
We moved like this.
Yes.
Now we are here. This is where we are. And you are now saying you want to be.
Yes.
Mitagonga wewe.
Sasa tanigonga mimi nimefanya nini?
So our next
Lakini
value,
wajamaa muko kunisumbua bure.
it's a negative. Okay?
Yeah, I'm saying it's a negative.
That means we are now going to get rid of this negative 1.5. So the answer is going to move somewhere here. This becomes negative 1.625. Okay? Forgive my thing wasn't that. So we are now, since the answer wasn't, this is a negative, right? Now we are now going to move over to
Edwin.
This one, yes.
You are complaining you did not get my argument. You first scroll.
Are we on the same page?
Yes. When you say that negative 0.05, are you getting it? Okay, negative 0.5.
What
and
is that?
And a 0, which is a positive, negative 0.4, which is a positive.
What is our new interval here, Dennis?
There's something I'm bringing before we reach down there.
Please, where do
I know the question once said a fourth iteration. I think 4. Was it 0.5? 0.5 for me, according to me. That is where our root lies. Because negative 0.5 is less than 0.
That's true. But
Yes.
the question is very clear. They want us to go to...
Okay, let's continue to the first iteration. Yeah, okay.
Wait, where is the question? Yeah, I'm looking at it here. The question does not say about the fourth. Okay.
Yes.
It does not say that.
Yes. So we have to stop at that. No?
Yes,
The
yes,
question
I
says,
did. I told you to just up to 4 so that we can see where the root lies.
Okay.
okay.
That's why we are going up to the 4th. But of course, one of you has already identified something.
That it's true, because if it wasn't, because I'm not seeing it on the question, that's why I'm like, yeah, we shouldn't.
Because I saw a negative and a positive, because a positive is much greater than that one.
So you first go to the root, to the 4th, and then now look through.
And now
Okay.
deduce. So we are now going to the 4th. So the C will be negative 1.75 minus 1.625 divided by 2.
That number is 7. We are writing it as 2.
Which number?
Negative 1.75. Okay.
Then we find is that 7525? It's me writing. You have to bear with me. What is the answer?
Negative 0.0096.
That's the 4th iteration. And the interval. Who is the owner? Paul, what should I write next?
We are done. Now the interval becomes, you go up where we got a positive. That one, negative 2 and negative 1.5. 0.5. Yes.
So the root is actually, what is the root?
The root is 0.531. It's not a negative.
0.5331. So I said the root. Okay. Dr. Chipin.
Edwin.
Yes, sir.
And you share that PDF.
Now, having written the root, let's go back on that interval you are talking about. There.
This one.
What is it? Is it 0.5331 or negative 1.75? Which one is the root?
The root is actually negative 1. This, because this is the C.
Yes. That gives us
This is the
the other.
evaluation of the function.
Aha, exactly. So the root is that.
-175.
Edwin, I'm sorry, why did we choose the -1.75?
Okay. Back to the top. We were given this. This was the first interval, right? -2 and -1. And we are saying the root assumes a value somewhere between these two figures. Okay? By default, if we are to choose even this 0.533, do you think 0.533 lies anywhere between these two? Good. So the actual root is actually 0 on the x-axis. So we are looking for this C is actually us trying to estimate the root itself. Our first try was this, trying to say maybe this is our root. It wasn't. Of course, by during that time we said it wasn't. We continue. Maybe this is our next root. We were trying to evaluate all those ones until we started seeing the zeros. And then we know for us to be able to get the root, R should be equivalent. And that's why we are settling down to this figure, okay, this one, because its evaluation gave us the closest to a 0. The closest to a 0.
I'm seeing the closest is the last one, the final one we evaluated.
We
How
always
do you?
prefer the positive.
Yes, we always.
Prefer the positive.
I remember Mr. Ssengendo explaining that we look at the closest, the one closest to X.
Oh, okay, let's do this. Are you saying this is closer to?
That is more extreme.
You think this is closer to 0?
Yeah.
Yes.
Than this?
Than 0.5.
And he also added that we always prefer the positive.
Mr. Paul, Edwin,
Yes, please.
you see, negative is not closer to 0. The one which is negative, closer to 0 is that 0.5.
We asked Mr. Ssengendo to elaborate on that.
Now, thank you.
Because negative has passed 0.
It's heading far away.
It's heading far away.
On a trajectory that is not nowhere heading. It's not tending to 0. It's
Because
tending
it's
away
like
from
now, you see, Edwin, it's like now you are going to Kampala, you are from Jinja going to Kampala, and you find yourself in Bombo.
always Maje thing. Bombo, there's a
It's coming because
This man. What? Okay. If we use the bombo thing, eh?
because it's a soldier.
Okay, fine. Let us use the bombo thing, eh? The one that we have picked is, let's say you are going to Kampala. Now, the 0.5
Is in
is
Mukono.
some. Okay, let's say bombo, eh? A far place to Kampala.
Oh boy,
But towards. Now, when we continue, again the other person passes by Kampala.
Mm-hmm.
And then he continues even to another place more than a bombo. And then we see him coming back.
Is in Luero.
And we see him now coming what? Back.
So he's going to take a double distance.
Yes. Exactly. So we are
Which
saying we are taking this man. Yes, he is in some place away from Kampala, which is lesser than 0.09, but this place is near Kampala than the other person who passed and then came back. You see, because we are not sure. Easy passing, he may even remain. He may
He
get
made
lost
them
there
there.
and he failed to come back.
Why did he pass if he knew where he was going?
Okay, those are those.
So in short, that's why we should always use the positive.
Yes, the
Yes,
first
that's why we
clear
prefer
positive to the
positives.
root. We have less time. Can we continue? We have less time, friends.
Okay.
Next question.
We normally give the root and the interval.
The root is
That one, and then the interval.
the interval. What was the interval? -2 and -1.5. Okay. Using Maclaurin series, find the
And you need, what word is that you've been written?
I didn't write interval.
You know,
I
things
told you.
that you understand.
X.
I'm
Let's
reading
continue.
Continental.
You're hungry, you want to eat. Number 3. Using Maclaurin series, find the first 5 terms of expansion of the function f. Function f of x. E. Dennis.
Yes, Edwin.
This question is yours, apparently, says Paul.
Is it mine or it's for the class?
For the class.
Okay.
So, wait, are people contributing or I should write?
Why me, Ron? We are contributing all over. Okay. Now that will be 3x, the first f1.
What, so you're saying, okay. So we do of
Okay.
f of x is equal to e, then we know Maclaurin's is centered at 0. So then we also get the f of 0. So can we get the f of 0?
F of 0 is 1.
So we find the first. What will be the answer?
3e.
3e of
3x. When you put at 0, it becomes 3.
Martin is asking what is his -0 and what is 0. So what is that now? Because still it is the same thing.
But how did you encounter with the -0? We don't have -0.
0.
That is the
Maybe
question.
you can explain that when water is at room temperature it's at 0, and then when it's now extreme, goes to -0.
Oh,
So can it be -0?
in politics,
When
in
you
politics,
multiply
it is called
nothing with a
Guys, we
-0,
don't have time.
Okay. F2 comes 9e x 3x Then f of 0 comes 9.
They said first 5 terms.
Bwana
Then we
Edwin,
go to
you are not showing the signs of first derivative, second derivative.
they are there.
When you are
No,
inserting in
on
zeros.
this side.
Thank you.
That is 27.
Evaluate. Give me the answer.
81E. Two, 4, 3. Then for macrolines, it is f into x.
F of x
is equal to f of 0 plus x f of f, first derivative of f, there is x first.
Let's repeat.
Okay.
It's
X
f of
times
what?
plus x times f, first derivative of
Where
0.
X.
Where are you getting x, Dennis?
Bwana Edwin, write first derivative of f 0, then include x, yeah, plus second derivative 0, x squared over 2 factorial, like that.
I said first 4, 5, eh?
I think those are 6 now.
Oh, first terms.
First terms.
One,
First,
two, okay. So we got
yeah, 3x plus 9x squared over 4 over 2. Twenty-seven x cubed over 6 is it 81? X power 4 x power 4
4 times, okay.
then plus dot 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 dot. Yeah.
So that becomes our answer.
Yes, sir.
Now that is okay, but you remove the dot because strictly we say the first 5 terms. Then you did not have to go to the 6th because we are not going to use it.
This part.
There
here.
is the other part, the
This
F5. Yes. That is okay, so we can continue.
Okay. The last one.
The last one is for Tugume.
Find the first 4 terms. This was number 1.
Tugume Andrew, take up.
Tugume must be sleeping, probably.
Yet he
No,
reads the numbers when you make a mistake.
No, I'm not sleeping.
Awake.
Okay, yeah. So we have to find the...
Read the question, sir.
Find the first 4 terms of the terrace.
Sin X. Okay. So we can find the terms, the first derivative of fx is called sin x.
You're not evaluating the first part.
The first part, no, we are not evaluating it. Yeah.
Why?
Then we put
Why
f
are you
of
not evaluating it?
it is the first derivative. So you substitute here. That is pi over 4, right?
Yeah.
Okay, so then you substitute pi into sin pi. You got sin pi over 4.
Is it?
This is centered at A, which is pi over 4. So when we have the function here, we need to evaluate that function and then get the value.
Yes, sin
Now it
pi.
is sin pi.
Someone can calculate and give us the answer. Sin pi over 4 is there is pi here.
You prefer to have the answer.
0.0137.
What is that in pi?
So that is 0.0137, right?
Yeah.
Doctor, do we need to keep, preferably, do we need to keep this in pi format?
I don't think so.
No, but pi is a value in radians, which means 180. So you're going to have 180 divided by 4 to get 45.
45.
So the sign of 45.
Oh, okay. Is 0.707.
Yes, but I prefer you use the root 2 over 2 or 1 over root 2.
Yeah.
Because that value you're writing, she has rounded off. Not so?
Yes.
Yes.
But root 2 over 2, you have not rounded off. Why are we interested in that? Because we normally round off at the last stage. If you round off at the initial stage, you're trying to create more errors as you go along. So even in our workplace, we always want someone who does the error at the end of the year.
When they are tired.
Yes, maybe we can accept such a thing. But if you're doing errors in January, February, then that means that probably what you're doing, you don't know it about, you don't know much information about it. Therefore, you're not a best candidate. So we accept to round off at the last stage non-intermediate stage. But still, I have to say I'm going to leave you because I have the next lecture. So I'm going to leave
But
you
how do
finish
you get
this
root
one.
2?
Sorry?
How do you get root 2 over 2?
Yes.
Sine of 45
That is
is
trigonometry.
a standard value. Yes, trigonometry. It's a standard value because 45 is an angle which has two sides that are equal. Two sides
So
that
I
are
can
equal,
do
and then the other side is 90.
Exactly.
Therefore, when you do that Soko Tower thing you have written, it becomes 1 out of root 2. And 1 out of root 2, if you don't want root 2 in the denominator, you can write it as root 2 over 2. So you are going to finish this number, but send me a snapshot of the answer, and then I will correct, and then I post back the group. If there is any mistake, if there is no mistake, still I will tell you that is okay. All right?
Okay, guys, we have 15 minutes. Let's finish this.
Okay. Nice time.
Thank you, sir.
You're welcome.
Thank you. That's negative cos x. Then f of, yeah. So, hey.
When you see, huh? Don't worry. Let me first write my trig here. Cos 45. Huh?
Shit.
It's the same, root 2 out of 2.
Root 2 out of 2.
Yeah.
Cos the adjacent.
You put adjacent 1, even
But I
opposite
think
1.
it's
Then I
negative
put
root 2 out of 2.
hello?
Root 2 out of what?
Negative root 2 out of 2.
Negative root 2 out of 2.
Yeah, then that is negative sine.
Negative sign.
Yes, x, which is equal to negative root 2 out of 2. And that's cos x, which is root 2 out. Is it true? Root 2 out of 2.
They said fourth term. So this is the first, second, third, and fourth.
Hey, here we go. Then we
Right. F of x is equal to
got f of x plus f of x into x minus 1.
x minus a.
Hmm? Yes, x minus a plus f of x, f of a into x minus a squared over 2 factorial 1, 2, 3. That's the last term. Okay, just like that. And we done. Tuchue the banana.
You need to replace my friend.
Then we put in those f of a root 2 out of 2 plus negative root 2 out of 2 x minus x plus minus a.
What is the A?
A is pi over 4 plus
It's negative.
Minus root 2 out of 2 times x minus pi out of 4 into, okay, squared 2 factorial over 2 factorial, then plus, that is root 2. Why are you getting root 2 out of 2 into x minus, oh, just like that, we are done. Congra, nice lunch, guys.
You need to simplify this thing.
Why are we complicating life?
Yes, to be honest, for me, I haven't understood the error, the very first number, that whole topic of errors. I don't know, the whole topic of errors, I haven't yet understood it.
Everything from where we started up to where we are is actually all errors. So you have to be specific.
No, that number, that very first number, that one you're showing right now.
This one?
Computing that, yes.
What didn't you understand?
First of all, from the topic, leave alone the questions, but the topic, like going through the topic of
do you know where we get this thing from? Please.
Yes, I haven't understood it, honestly.
Where we arrive, the Rn.
Yes, I haven't understood yet.
Okay. Please don't write. This is not part of the thing. Paul, is Paul still part of the call? Oh, yeah, me, I want to guys. Can you text the guy the answer, eh? Please, doctor.
You want to simplify it further, Edwin?
Sorry?
Edwin, you share that document to us.
This document has literally all my notes, so I may not be able to share.
Why not?
You're going to see a lot of things there that do not help. It has a lot of written stuff of completely different stuff, including work.
You have other things there.
Yeah, I have other things. There are a lot of documents. There are 14 pages.